Good morning.
Good morning.
All right, so it looks like we have no Holbrook or Joseph City. Oh, okay. Hey, you made it.
Yeah, I'm here. I was running a little late. I'm sorry.
All right, good. Well, I know you were testing this morning, right?
No, I wasn't testing, but I had to check in with my
Oh, okay. Okay. Well, I know Holbrook is testing, and I think Joseph City is. I was really worried that Winslow was testing too, so um, I'm glad to see y'all here. Is everyone present in Winslow? It should be. It looks like we got extra people there.
Yeah, everyone's here.
All right, and then how about Caden? Is Caden here?
Yes.
Okay. All right. Okay, so just a couple of things before we get started. The Just to let you know about a couple of extra credit opportunities. The first one is, and both of them were like the evaluations from last semester. So there's one on the Moodle that's just kind of a click or different rating system about the class. And so on that one, I think I'm going to be opening that up tomorrow, and it shouldn't take you very long. But what I'm going to try to do is give you 5 points on your quizzes if you take that. So, like if you got a 0 out of 5 on a quiz, it'll make it 5 out of 5. Or if you've got 4 out of 5 on 5 quizzes, it'll give you 5 out of 5 on those. So you get 5 quiz points for taking that. And then I'm still going to have you do the written evaluation. I'm going to change it up a little bit. I'll tell you more details about that probably next week. But we will, I still would like you to do a 1-page written evaluation, and that one will be 5 points on the final exam. Okay, so we've got those two coming up. All right, so today we left off on a problem here. I'd like to do an example using the summation, but before we start in on that, does anyone have any questions? So, go ahead.
Sorry. When when are the quizzes for chapter 9 due?
Let's see, when the test closes, then everything's going to close. Okay? So I think that is, let's check the Moodle really quick. Okay. So it'll be a week from today. Is that everything? So once it's going to be a week from today.
Okay, because the 9.1 through 9.4, 2 of them close today and 2 of them close tomorrow.
Yeah. So once I get that final date, then I actually go back in and we'll readjust those. So they'll be open. If they're not open right this second, I'll reopen them. Okay. So thanks for bringing that to my attention, though. I appreciate that. And Joseph City, can you guys see me?
No.
Okay, but you obviously can hear me. Yeah, you guys have dropped off. So you might have Ms. Buckley call in to talent support if you don't get back in the next couple of seconds.
Okay, well, she's not in the room right now, so I'll let her know when she comes back.
Okay. All right. And thanks again for that heads up. So all of the quizzes then will be due a week from today. Also, the other thing I was going to say, Winslow, do you guys know when you're doing the next AZ Merit test?
Tomorrow. It's gonna be
Tomorrow?
And then
all of April.
the
Basically.
juniors are next week.
Okay.
Because
So-
it's not.
Okay, so tomorrow that doesn't affect us. So anyway, so just let me know if you guys are going to be, if the majority of the class is going to be gone any day for testing, because I know April is crazy. So I just kind of want to be ready
Today.
today.
That was earlier in the morning.
Yeah.
Earlier this morning.
Right. So yeah, Holbrook has that today too. So, but if there's a day that if any of the tests encroaches upon our 11 o'clock slot, then just let me know. Okay, that would be great. So, anyway, well, thanks again. So let's get back to our lesson here. So what I wanted to do is show you how to, wait, why are we not seeing it? Okay, hold up. Okay, there we go. So we were talking about this, the sigma notation or the summation notation, okay? And so, so just to kind of go through this, is that the lower number is the number that you start with when you're plugging in. So here we're going to start with 3, and then you go up 1 each time, and then you're going to end at 6. So you start in with 3, and so you'll have 1 plus 3 squared. So you're plugging in 3 for k. Then you have 1 plus 4 squared, 1 plus 5 squared, and 1 plus 6 squared. And then you just crank it out. All right. So then that would be 1 plus 9 is 10. 1 plus 16 is 17. 1 plus 25 is 26. 1 plus 36 is 37. And then you just add those and get 90. So when you do the summation ones, then you get a number. Okay. So your final answer should be a number. Okay. So let's have you try practice 2B, please. All right, so Andrew, when you've got it.
I'm not sure, Mr. Strong.
Okay. So first you plug in 4. So you'll have 3 times 4 squared. So what's that?
Yeah, 144.
48.
Oh, 12 squared.
So 3 times 4 squared. No, just the 4 is squared.
All right.
So it'd be 3 times 16.
48.
Okay. Then you plug in 5. So it'd be 3 times 5 squared.
225.
No, because you do 5 squared is 25 times 3 would be 75.
Yeah, okay.
Okay. And then you do 3 times 6 squared. So, which is 108. And then the summation symbol means now you add up those 3 numbers. So 48 plus 75 plus 108. So what do you get?
231.
Okay, so 231, that's the answer. Okay. All right, let's do another one of those just for fun. Okay. Let's not do that one. Okay, so let's do this one. The summation as I goes from 3 to 7 of 2i divided by 5. So let's try that. So just kind of write that in your notes or on the side of the paper. All right, so Rex, when you've got it. Oh, let's see, Rex, can you hear me still? All right, well, hopefully they'll pick it back up. All right, so Cameron, when you've got it.
$10.
10? All right. So let's see. First, you plug in 3. So 2 times 3 divided by 5. Then you plug in 4. 2 times 4 divided by 5. 2 times 5 divided by 5. 2 times 6 divided by 5. And then finally 2 times 7 divided by 5. And then you add all those up. You can do them in your calculator or you can work out the fractions. You get 50 divided by 5, which is 10. All right, so great job. Any questions? All right, so let me show you kind of a shortcut to use your calculator. If you have a graphics calculator, it will actually have the summation a key for it, okay? So let's go to that. So if you press the math key, And then as you arrow down, to option 0. Whoops, I went too far. So I guess you can go up if you need to. But so if it's summation, sigma. Now, if yours doesn't have it, it means you've got an older calculator. And you just have to, you could put all that in the calculator, but it's not going to have the shortcut. So you go down to the summation, press enter. And so then it lets you put in the index. So now you can put in I, or it doesn't matter what the variable is. So just because it has a variable key, so I'll use X. Wait, hold up. I'm in the wrong mode here. Yeah, I was in parametric mode. Okay. All right, let's do math. Okay, so then I'm going to press X equals, and then the lower limit is 3. And then you can just arrow up to the next one. So from 3 to 7. And then inside the parentheses, you put the formula. So that would be 2x divided by 5. And then arrow out. Then press enter. And boom, there's 10. Okay? And so that's kind of a nice little feature of the calculator where it has the summation notation. All right? Any questions on that? Okay. All right. So what we've been doing up to this point is sequences. Okay. Now, if with the summation, if we're actually adding up the terms of a sequence, then that's called a series. Okay. So the sum of the terms of a finite or infinite sequence is called a series. All right. So again, the finite series is where you have a certain number of terms that you're adding up. Now, so let's suppose that you have a finite series or even an infinite series. If you add up the first n terms, then that's called a finite series or an nth partial sum. So that kind of might sound strange, and a partial sum. But what that means is, suppose that you have an infinite number of terms and you want the third partial sum. Then that just means you just add up the first 3 terms. Okay? So a partial sum just means you're adding up the first so many terms. Okay? The sum of all the terms of an infinite sequence is called an infinite series. Now you might say, well, how can you add up an infinite number of things? Well, I'm going to show you that we can actually add up an infinite number of things. Okay? Now, when we add up an infinite number of things, an infinite series, then the summation, the upper limit of the summation becomes the infinity sign. Okay? Now, the problem that this gives us is if we get used to putting those other ones in the calculator, you can't put infinity in the calculator. So you can't do these in the calculator. So you have to know how to do them by hand. And I'm going to teach you how to do that. Okay? But when you can't put in infinity up there. Okay? If a sequence of partial sums of an infinite series approaches a fixed real number, we say that the series converges. So it adds up to a certain number. If the sequence of partial sums does not approach a fixed real number, either by getting larger and larger or bouncing around, we say that the series diverges. Now, so like in calculus right now, the chapter that they're working on is exactly this series, this idea with series. When you add them up, do you get a number? In which case the series converges, or if it doesn't, it diverges. And so that's what they're working on right now, is with these infinite series. All right. So this would be an example of that, like what we would be doing in the calculus class right now. You're wanting to know, does this series converge or diverge? Okay. It's kind of hard to look at that and just say. So one of the tricks that I try to teach my students is to write down some of the terms just by plugging in. Starting with 1, just plug in 1 for I. So that would give you 1 over 1 minus 1 over 1 plus 1. So that would give you 1 minus a half, which is a half. So that's the first term in that infinite series. Okay. Now, to get the next one, we would then look at what happens when I is 2. Okay. So the first sum, the sum of the first term is just a half. That's just the first term. The sum of the first 2 terms is a half plus, so the last answer, plus, now when we plug in 2, we're going to get a half minus 1 over 2 minus 1. So that's a half plus a half minus a third, which is 2/3. All right, let's try one more. So the S3, the sum of the first 3 terms, we take the 2/3 plus, and then now we're going to plug in 3. So that would be a third minus a fourth. So that's 2/3 plus a third is 1 minus a fourth is 3/4. Now, as you look at these sums, can you tell if they're getting bigger, if they're approaching a number? What do you think? So it starts with a half, and then 2/3, and then 3/4. What's the pattern? What would the next one be?
4/5.
4/5. And then 5, 6, 6, 7, so on. So what number is that approaching?
0.
No. They're not, it's not getting smaller. These numbers are, 2/3 is bigger than a half. 3/4 is bigger than 2/3. 4/5 is bigger than 3/4. So it's not approaching 0, but that does a lot. But what number are they approaching? 1. Okay. So their sum is approaching 1. So we would say that this series converges to 1. Okay. It converges to 1. So it's getting closer and closer to 1. All right. So let's see if you can do practice 3. So again, you want to look at the first few terms and just see if you can figure out what's going on. All right, so Taylor, what do you think? Does the sum approach a specific number or not?
No.
No, it doesn't. Because, see, what happens is the first term is just -1. -1 to the first is -1. But then the second number is 1. So that sum is 0. All right, but then you look at the third term, and it's also -1. So 0 plus -1 is -1. Well, so this sum, and the next one will it keeps bouncing back and forth. The sum keeps bouncing back and forth between -1 and 0. So then we would say this diverges because the sum doesn't approach a specific number. Okay? All right. So that's just kind of a little precursor to how we're going to use series in calculus. I mean, we spend 2 or 3 weeks on it. Whereas right now we've spent 5 or 10 minutes. So, but anyway. Okay, now next on the sheet was the Fibonacci sequence. Does anyone remember from yesterday the first 7 terms of the Fibonacci sequence? What does it start with? 1, and then
2.
Yeah, the first 2 numbers are 1. So it goes 1, 1, and then after that, it's the sum of the previous 2. So it goes 1, 1, and then what? 2, and then 3, and then 5, and then 8, and then 13. Because the last 2 were 5 and 8. So you look at the last 2 and you keep adding those up. Okay. All right, what about the formula for this Fibonacci sequence? Does anybody remember that? I had that up yesterday. Well, there's a couple of ways you can write it. But basically, if you say that the nth term is the sum of the previous 2 terms. So a sub n minus 1, that's like the last term, plus, and then the term before that would be a to the n minus 2. Okay? So the term that we're on is the sum of the 2 previous terms. That's kind of how you would write the formula. Okay. All right. So so on the sheet where it talks about sequences and series, part 5, I think we're gonna just skip that. But I do want you to do practice 5A. So this is find the 5th term of the sequence. A sub n equals 3 to the n plus 1 over n. So here, all you're going to do is just plug in a 5 for n and then work it out. Okay? So see if you can do that for me. All right, so Lana, when you've got it.
48.8.
48.8. That's it. Okay, good job. All right. Any questions on that? Okay, so now let's see if you can remember how to put the summations in the calculator. So the last practice problem here, 5B, says use the calculator to check your work to practice 2A. So we initially did that one by hand. So now I want you to put it in your calculator and see if you get the same answer. All right. Anyone have any trouble keying that in? Anybody get a different answer than what we got before? Okay, so now I've got an extra one I want you to put in there. And it's this one. And it says, find the third partial sum of the infinite sequence. Okay, so see, you can't plug in infinity into your calculator there. But since it just says find the third partial sum, then you can just plug in 3 in place of the infinity. And so now you can put that in your calculator. All right, so Taylor, when you've got it.
.555.
Okay. All right, very good. Or if you had it as a fraction, that's fine too. All right. Any questions on that? Anyone having trouble keying that in? All right. Okay, so that's it for 11.1. So now we're going to look at start 11.2 today. Okay, so we've been working with sequences and series and partial sums, and now we're going to continue that and focus specifically on arithmetic sequences. All right. Does anyone remember maybe from Algebra 2 what an arithmetic sequence is? Ready? Okay. It's where you add the same number each time. Okay. That's arithmetic. Whoops. We got some more of these things here going on. Okay. So a sequence is arithmetic if the difference between the consecutive terms are the same. All right. So the number D is called the common difference of the arithmetic sequence. So if any two consecutive terms, if you subtract, that's the D. That's the common difference. And it should always be the same. So like 2, 4, 6, 8, 10, you're adding 2 each time. So that's the common difference. Okay. All right, so here, if this is my arithmetic sequence, 7, 11, 15, 19, and so on, then if I take any two numbers and subtract, so 11 minus 7 is 4. So 4 is the common difference D. Okay? So since the difference is 4 between all of them, then it makes it a common, an arithmetic sequence. Okay? All right. So this says write the first 5 terms of this sequence. Determine whether the sequence is arithmetic, and then if it is, find the common difference. All right, Alana, when you've got it. Well, actually, let's break it up. So, Alana, you just tell me the first 5 terms.
Five, 8, 11, 14.
Yeah?
14. And 17. And 17.
All right, very good. All right, so Jordan, is this sequence arithmetic?
Yes,
And what's the common difference?
it's 3.
3. Very good. Any questions with that? All right. Okay, so like here, the difference between these two numbers is 3. The difference between these two is 5. The difference between these two is 7. Now, this is still a sequence. It has a pattern, but it's not arithmetic because you have to have the same number, go up by the same number each time for it to be arithmetic. Okay? So, So this is give an example of a sequence that is not arithmetic. Okay, so just kind of write one down if you can. All right, so Rex, do you have a sequence that's not arithmetic?
No.
Okay, just give me a number.
3.
3. All right, give me another number.
7.
7. Okay, so 3 and 7. So the difference there would be 4. All right, so now give me any number except 11.
10.
10. Then that is not arithmetic. So 3, 7, 10 is not arithmetic. Because you just can't go up by, if you went up by 4 each time, that would be arithmetic. Okay? All right. So other examples, you could say, like the hours on a clock. Okay, it looks like it's arithmetic for a while, but then it goes back to 1. Or the cube, perfect cubes. Okay, or just, what sequence is this?
Fibonacci.
The Fibonacci sequence. And so it is not arithmetic because you don't add the same thing each time. Okay, all right. Okay, now, the nth term of an arithmetic sequence, so any random term, has the form a sub n equals dn plus c. So you take the common difference times, like if you're on the 5th term, you take 5 times the common difference, and then plus c, where c is a constant. Okay? Now, this formula is not in your book, but I would recommend that you write it down on your paper, because this is a way that if you know the first term and you know the common difference, then you can find any specific term. Okay? So that's a great formula to have. Okay. So this let's see. All right. So it says find the formula for the nth term of the arithmetic sequence whose common difference is 3 and whose first term is 2. All right. So I'm going to use that second formula that I gave you. So a sub n equals the first term plus n minus 1 times d. So the first term, the a sub 1, it says whose first term is 2. So your a sub 1 is 2. The common difference is 3. So that's my d. I'm going to plug that in for d. All right. So then you say, well, then a sub n equals, so the a sub 1 you plug in 2, for the d you plug in 3, and then you simplify. So distribute and you'll get 3n minus 3, combine like terms, and you get a sub n equals 3n minus 1. And so that's kind of the formula then. And then, so then once you have that, then you can find any term. So like if I had to find the 10th term, then I would just say, well, it's 30 minus 1, 29. You just plug in whatever n is. Okay. All right. So see if you can do practice 2A. All right. So Jordan, when you've got it.
I have 8n equals 5n minus 6.
All right. Excellent. Any questions on that? Anybody like me to go through that? All right. Okay. So now, suppose that we're not given the D. Then we have to figure out what D is. So here, a sub 1 is 7, a sub 2 is 3. Now, in this case, since the first number is bigger than the second one, the D is going to be negative. So to go from 7 to 3, you would actually subtract 4. So here your D is going to be negative 4. So then once you calculate D, now it's like the last problem where you plug it into the formula. So you're going to have a sub 1 is 7 and your D is negative 4. So again, you distribute and you get 7 plus, then when you get negative 4n plus 4, combine like terms, and you get a sub n equals negative 4n plus 11. Okay. All right, so go ahead and try practice 2B.
Could you show us the practice question, please?
Oh, sure, absolutely. All right, so Shannon, when you've got it.
(12n minus 4).
A sub n equals 12n minus 4. Great job. Great job. Any questions on that? Would anyone like me to work through that? Okay. Now, the next one is a little trickier because let's see here. Okay, because we're not given the D or the A sub 1. Okay? So we have to actually figure out both of them. Okay? So here it says the fourth term of the arithmetic sequence is 20. The 13th term is 65. Okay? So what you do is you say, all right, well, A sub 4 plus 9D is equal to A sub 13. Now, where did this 9D come from? Can anybody tell me where this 9D comes from?
4 and 13.
Yeah, from the fourth term to the 13th term, there's 9 numbers. So you got to add the D in 9 times. Okay? So you say A sub 4 plus 9D is A sub 13. So the A sub 4 we're going to plug in was 20. The 13th term is 65. So then what we do is solve that for D. All right? And so then we subtract 20, divide by 9, and we get D is 5. Okay? So we're going to add 5 each time to get to the next term. So that means that to get to the previous term, we could subtract 5. Okay? So that what that means is that if A sub 4 is 20, then if we count backwards, see 20, subtract 5, A sub 3 would be 15, 10, and then 5. So what that means is that the very first term, the A sub 1, is 5. So here we have A sub 1 is 5 and D is 5. So now when we plug into our formula, we're going to get A sub n equals 5 plus n minus 1 times 5. So then when we distribute here, we're going to get A sub n equals 5n. So that's going to be the pattern. Okay, so I want you to start on practice 2C. I'll put it up in just a second. If we don't finish it, finish going over it, we probably won't. Then we'll start with it on Thursday. But I would like you to try to work through it here. So let's put the problem up. Okay, so find a formula for the nth term of the arithmetic sequence. The 8th term is 25 and the 12th term is 41. Okay, so you don't have to write the 5 terms. So just figure out the formula, the A sub n. Okay, so I see we've only got 1 minute to go. There's no way we're going to finish it in 1 minute. So if you would just please do that before class on Thursday. I will change all of the deadlines for all of the quizzes to chapter 9 to till they won't expire until a week from today. Okay. And then otherwise, if you need tutoring or whatever, please take advantage of that. If you need